Gibbs free energy and Helmholtz free energy. Let us take the first one, Gibbs free energy. A spontaneous process involves an increase in the entropy of the system and proceeds towards equilibrium. Thus, a spontaneous process proceeds in the direction in which delta S of the system is maximum and delta H is minimum. Fill in the blank question. As suggested the second law of thermodynamics, delta S total is equal to delta S of the system plus delta S of the surrounding. Can be used to predict the spontaneity of a process. For a spontaneous process, delta S total is always positive. The determination of delta S total, the determination of delta S surrounding, which is not always possible. That means in order to determine the delta S total, it requires the determination of delta S surrounding, which is not possible. Hence, a new thermodynamic function known as Gibbs free energy is used to introduce to explain spontaneity of the process. In order to solve the problem of determining the delta S of the surrounding, which is very difficult to determine. Gibbs free energy and free energy change. Gibbs free energy change is a very important thermodynamic function and is represented by capital letter G. It is defined as follows. The maximum amount of energy available to a system during a process for doing useful work under constant temperature and pressure conditions is called Gibbs free energy. Mathematically, Gibbs free energy is given by capital G is equal to H minus Ts, where H represents the enthalpy of the system, S represents the entropy of the system, and T represents the temperature of the system in Kelvin scale. Gibbs free energy change. Gibbs free energy is a state function. Therefore, the change of Gibbs free energy depends only upon the initial and the final state of the system and does not depend on the path by which the change has been carried out. The change in Gibbs free energy is represented by delta G. An expression for delta G can be obtained as follows. That means we are going to derive an equation. By listening to the audio, if you are also able to derive the following equation and get the final answer, then we can feel that you understood the derivation, how delta G is derived. The Gibbs free energy is given by G is equal to H minus T1, equation number 1. That is called the Gibbs free energy. Since H is equal to E plus PV, that means enthalpy is equal to internal energy plus the product of pressure and volume. Substituting this value of H in the equation number 1, we get G is equal to E plus PV minus Ts, equation number 3. The change in free energy can be represented as, that means actually that is we are considering G1 is equal to H minus temperature is made constant, and if T1 not different temperature T1 and T2, that means H minus T1 S1 and G2 is equal to H2 minus T2 S2. That means from that G2 minus G1. G2 minus G1 is equal to, that means this H are replaced by E plus PV. Therefore, you write another equation to see that E plus P1 V1 and P2 V2 for G2. Then G2 minus G1 is equal to delta G. And E2 minus E1 is equal to delta E. P2 minus P1 is equal to delta PV. This we have to expand. That means P1 V1 and P2 V2 if you minus P2 V2 minus P1 V1, it is equal to delta PV. Similarly, T1 S1 T2 S2 T2 S2 minus T1 S1 is equal to delta TS. That is how these values you get, delta TS. You have to do systematically and get this equation number 4. After that, mathematically expand it. You know the expansion, how to do it. Delta G is equal to delta E, no problem. Delta PV is equal to P delta V plus V delta P. This is the expansion of this delta PV. Similarly, after putting a minus sign, delta TS means T delta S minus S delta T. S delta T. This section you should expand it by yourself and see that whether you are getting this answer, which is equal to equation number 5. If the change is carried out at constant temperature and constant pressure, we have delta T must be equal to 0. At constant temperature, there is no change in temperature. At constant pressure means no change in pressure. Delta P is equal to 0. Then you can cancel certain terms in this equation. That is delta T. This can be cancelled. That is, it is equal to 0. And delta P, that is, this factor is equal to 0. Therefore, the equation becomes delta G is equal to delta E plus P delta V plus 0 minus Ts minus 0. Cancel all the zeros. Then delta E plus P delta V minus T delta S is the only thing which is remaining. Let it be equation number 6. From the equation 2, that is from the equation 2, we know that H is equal to E plus PV. Therefore, delta H is equal to, that is, as I told you, H1 is equal to E1 P1 and H2 is equal to E2 P2. H2 minus H1, that is equal to delta H, is equal to E2 minus E1, that is delta E, and P2 minus P1 is equal to P delta V. Therefore, substituting in equation number 6, that means we know delta E plus delta P, delta E plus delta V is equal to delta H. This is delta H. Substitute that value here. That is delta G is equal to delta H minus T delta S. This is the change in Gibbs free energy change. Follow all the steps and derive the equation by yourself. See that whether you are getting equation number 7, which represents the free energy change in a process occurring at constant temperature. That is why delta T kept 0. And at constant pressure. That is why delta P is 0. This equation is referred to as Gibbs-Helmholtz equation. Very, very important for the examination point of view. Derive a relationship between Gibbs free energy and Gibbs or Gibbs-Helmholtz equation. That means delta G, a relationship of delta G.